Kia ora, and welcome to a lesson on Cambridge Mathematics P2 and P3, Modulus Inequalities. So, for modulus inequalities, the first thing you need to know is how a modulus function reacts with an inequality symbol. So let's have a look at the most basic variety of moduluses, which is mod x, and then let's say that is less than a. Okay. So in terms of your inequality, that's saying that any value on the left hand side, the modulus x side, will be less than the a value. So on a number line, that will look like this. So every value is below a. However, because this is a modulus function, it's not going to go on forever, because on my negative side, if I have a negative value which is greater than an a value, that would not satisfy this inequality. So this will only go to minus a. So all the values that will satisfy this inequality for x is between positive a and negative a. What about if I have modulus x is greater than a? Well, that gives you x is going to be bigger than a, and also x will be less than minus a. So one of the ways you can rewrite this is x less than a greater than minus a, and x is less than negative a, x is greater than positive a. So that's how the modulus function interacts with the inequality. Let's have a look at a more complicated question, and for each of these I'm going to do an algebraic method and a graphical method. So the first example I have here is modulus 2x minus 5 is less than 3. So another way of writing that is saying that 2x minus 5 is less than 3 but greater than negative 3. And now I can solve each one of these inequalities either simultaneously or separately. So simultaneously I can just say, well, add 5 to both sides. So 2 is less than 2x less than 8. So therefore x must be divide both sides by 2, 1 and 4. So x is greater than 1 and less than 4. I could have separated those out into two separate inequalities and solved them separately, then put it back together, but it's just as easy to do it as one inequality. Let's have a look at how this would look graphically. And it's not necessarily going to be easier graphically, but some questions later on may be easier graphically, so it's worth still paying attention. So, how would I do this graphically? Well, I would say that I'm going to graph the equations y equals 2x minus 5, sorry, modulus 2x minus 5, and y is equal to 3. And then look at the points of intercepts to help me work out this equation. So, what would the graph y equals modulus 2x minus 5 look like? So, if you watched my previous lesson, we looked at how to find the vertex point of this. So the vertex of modulus 2x minus 5 will be at x is 2.5 and y equals 0. So here at 2.5. And it's a graph which goes has gradient 2. So every one along it goes 2 up. And the intercept at the y-axis will be at positive 5 because it's modulus of the minus 5. And then it will look something like that. Okay, that's what our graph would look like. The y equals 3 graph is just a graph which is horizontal through 3. Like so. So we get 2 points of intercept. One on the negative downward side of the modulus graph, and one on the positive gradient side of our modulus graph. So what we can think about is, what is the equation of the negative graph? Well, that would be the graph y equals minus 2x plus 5. And we want to find out when that is going to also be equal to 3. And then the other graph is the y equals 2x minus 5. And that's when y equals 3. So this is y equals 2x minus 5 when x is greater than or equal to 2.5. This is a graph y equals minus 2x plus 5 when x is less than or equal to 2.5. And now I can use this to separate out and solve. So substitute y equals 3 into both situations. I get 3 is equal to minus 2x plus 5. 8, sorry, not 8, minus 2 is equal to minus 2x, so x is equal to 1. And then 3 is equal to 2x minus 5, which is 8 is equal to 2x, which is x is equal to 4. So all that is telling me is that my graph is intercepting at 4 and at 1. I can see how the inequality is working here. So modulus 2x minus 5 is less than 3. I want to find out when I am below 3. And I'm below 3 between 1 and 4. So x is greater than 1, x is less than 4. So that was quite a few more steps compared to the algebraic version. However, it is a potential method on some of the harder questions. So don't just assume, oh, I'm going to ignore this because the algebraic version is much easier. So let's have a look at another question. Modulus 2x minus 1 is greater than or equal to modulus 3 minus x. So again, if you've watched the previous videos, you'll have seen when we've had modulus on both sides, one of the ways to get rid of a modulus is to square out both sides. So I'm going to square both sides here. So 2x minus 1 squared is greater than or equal to 3 minus x squared. And then all I need to do is expand both brackets, make it equal to 0, and then solve it. So 4x squared minus 4x plus 1 is greater than or equal to 9 minus 6x plus x squared. Going to take everything to the left hand side of this equation. So 3x squared plus 2x minus 8 is greater than or equal to 0. And I can either use quadratic formula or factorising. If I can factorise it, which I can, I've got 3x, I've got x, I've got plus 2, and I've got minus 4. Okay, so now I've got it to this point. Solving it, you can't really use the equal sign because we've got an inequality. You can substitute an equal sign in and then do a test between the 2 points, or you can do this graphically. So, thinking about this graphically, what does the graph 3x squared plus 2x minus 8 look like? Well, x, y. I know if I was to say this is equal to 0, 3x minus 4 is equal to 0, then x would be 4 over 3, so that would be one of my intercepts. And then the other one would become x plus 2 is equal to 0, so x equals minus 2, so that's going to be my other intercept, which is on the other side. Okay, and it's a positive quadratic graph, so it's going to look something like that. Well, something a bit better than that, but something like that. And I want to know, when is this graph greater than or equal to 0? So that is when it's above the x-axis. So when is it above the x-axis? It's above the x-axis when it's greater than 4 over 3, but less than minus 2. So my solution is x is less than or equal to minus 2. x is greater than or equal to 4 over 3. How about solving this graphically? Okay, so I know I've used a graph here just to help me find out my final inequality, but I can use a graph from the beginning. So, to use a graph from the beginning, all I need to do is split this into my two different equations. So I've got y equals modulus 2x minus 5. I've got y is equal to 3 minus x. Sorry, I'll do that in a different colour. Y is equal to modulus 3 minus x. I'm going to sketch these two graphs and look at where they intercept one another. So the graph y equals 3 minus x will touch the x-axis at 3. It will go something like that, where it would cross here also at 3. And then the 2x minus 5 will touch the... Sorry, 2x minus 1. Managed to write that down wrong. 2x minus 1 2x minus 1. 2x minus 5 was the last one we did. 2x minus 1 will touch the x-axis at 0.5 and cross the y-axis at 1. And it's going to be a bit steeper, this one, because the gradient is 2. So it's going to go up something like that. Something like that. Not the best sketch in the world, but a sketch is a sketch. So from this you can see clearly where the two graphs intercept. They intercept here and here. Okay. So all I've done here is find a quicker way of finding the points of intercept, because I don't need to consider this part of our modulus graph here, because the gradient is lower than the gradient here, which means that no matter what, these graphs and these lines are never going to intersect. Okay, this line is never going to intersect with either one of those lines. The only one I need to consider is what is the equation of that line, and then the equation of this line and the equation of this line, and where they intercept one another. So my mod 2x minus 1 graphs are, when separated, y equals minus 2x plus 1, and y is equal to 2x minus 1. And the downward side of this graph is my negative gradient side, which is y is equal to 3 minus x. Okay, so you have to do a bit of thinking. It's not always just going to be the negative part of that. It's you have to think about which gradient you want. So we wanted the negative gradient variety and not the positive gradient, which would have been the y is equal to minus 3 plus x. Okay, so now all I need to do is substitute y equals 3 minus x into either one of those two equations to find my two solutions. So 3 minus x is equal to minus 2x plus 1, which becomes 3 plus x is equal to 1, so x is equal to minus 2, and then 3 minus x is equal to 2x minus 1, which becomes 3 is equal to 3x minus 1, which is 4 is equal to 3x, x is equal to 4 over 3. Okay, so same solutions as I got a second ago. Now I just need to consider, when is the graph 2x minus 1 greater than or equal to modulus 3 minus x? So that is when it's above the red line here. So when it's above that, which is when it's greater than what would be 4 over 3, and when it is greater than, what would be minus 2. Okay, that is when it's greater than the red line. So my two solutions, sorry, when it's less than minus 2, not greater than minus 2. My two solutions are x is less than or equal to minus 2, x is greater than or equal to 4 over 3. Okay, so that's two different questions shown both algebraically and graphically. Main things to consider is when you take the modulus out, you get an inequality either side of the x or less than or greater than. So that's everything. Thank you for watching. Hopefully you understood that. Good luck with your questions, and I'll speak to you again soon.